Alright guys, I'm back with another video. So in this video I'm going to attempt to demystify or clarify some things, maybe some misconceptions that some people have had, uh, and some of this is related to things that people have approached me about. So first off and foremost, I do want to say that the way that I set this up in here probably isn't the intended way for this to be set up using the Unreal animation system or motion matching system. So root motion from everything is probably not what you're going to want unless you have a big game studio with a dedicated motion capture studio, or you run a motion capture studio. If one of those is the case, then maybe you'll want to use this. So for everybody else, you're more than likely going to be using root motion from montages only. Even if you do have a motion capture studio, then you'll probably end up using that anyway. So there is this offset root bone node, and this seems to be used for non-root motion based systems to try to mitigate foot sliding. It allows your character to pass outside of the capsule. What it does is it offsets them based off of your current velocity and the velocity that they're supposed to be moving at in the animation. And then it kind of interpolates it in some way. There are different settings here for different scenarios. I'm not going to go into that because I haven't really figured that part of it out yet. I'm not really sure when you would want to accumulate versus interpolate or hold or release. But I may go into that in another video, but I'm not really going to go into that in this video. But I will say that the offset root bone does have some amount of desynchronization during multiplayer replication. I will also say that root motion from everything has desynchronization and rubber banding problems. I will also say that even without root motion from everything, I have seen some problems with replication. And I'm going to go over that in this video, as well as some other things. So before I move on from motion matching with root motion, then I want to first cover some things and clarify some things. So I think previously I was under the impression that the character movement speed settings actually had no effect on the motion matching system when you were driving it through root motion, but that actually doesn't seem to be the case. So the max walk speed, I can confirm, seems to be some kind of a soft cap. So right now I set it to something very low, just to show you guys. So you'll see that it doesn't really seem to be responding that well. Now he's going. But you'll see it's kind of throttling up and down. Now the reason why he keeps slowing down and stopping, and the reason why it didn't start very quickly, is because I believe I modified the continuation cost bias. So let me just check that. Yes, I did lower the continuing pose cost bias. So if I reset that to that higher number, 0.01, then it may not do it. Yeah, so see, it's more responsive now. So the thing to take away from that is don't lower your continuing pose cost bias too far, because in case people are confused, because a lot of people are confused as to what the continuing pose cost bias is, just think of it as a continuation cost. So the cost to continue this animation frame by frame by frame, just like you would normally play it. So in a motion matching system, it's going to wait all of these frames, and it's going to jump around to different frames depending on which one has the next best or the next lowest weight. So whichever one has the lowest weight will be the pose that gets played next. In some situations, you might jump pretty far across the animation or to a totally different animation altogether. It depends on your setup. So in the one that you just seen, I only had two dance cards. And in this one, I'm using regular animations. Animations like you would normally see on an animation graph for a game animation system. Whereas these dance cards aren't something that you would normally see inside of a game. And the reason why is because they're not looping, they're not transitions, it's one continuous flow of animation. Now, what is a dance card? So whenever Ubisoft was researching the motion matching ideal, they realized that one of the main limiting factors would be memory due to animation size. So you can see these animations, this animation right here is pretty long. It's it's almost 10,000 frames long. So in order to keep the animations like from being several hundred thousand, from being several 100,000 frames of animation, what they did is they sought to figure out if they could choreograph a dance routine or a movement routine that would cover all the different trajectory movements that they need for their animation system while minimizing the number of frames needed, therefore reducing the memory overhead. And so they experimented until they found these dance routines that covered all the different motions that they needed for their animation system. And that's what they went with. So that's where the term dance card came from. So this requires about 12 meters by 8 meters of space. I've already took this animation in particular out and I measured it in Unreal, and it's 12 meters by 8 meters. So in actuality, they probably used more space than that because the cameras have to be so far away from the actor to actually properly track them. And they used optical cameras. Now you can try to use a inertial suit, but just know that inertial animations, the cleanup on them is horrendous. It's a lot of work to clean up even small animations, much less very large ones like this. So I wouldn't advise trying to clean up 7.5 to 10,000, maybe even 15,000 frames of animation that was captured via inertial suit, because inertial capture is very, very inaccurate, especially when it comes to velocity, which is why the feet are constantly sliding in the animations, and you have to go back and fix the foot sliding. And the reason why is because it does not accurately track velocity. So it also has no spatial awareness. So if you go with an inertial suit, you might want to go with like one of the most expensive top of the line ones out there. You might be able to get by with that, and it could save you 60,000 or more in money towards a proper system. So with that out of the way, basically bottom line, most of y'all are not going to be using dance cards. Now there is a Motorica, and currently right now they have a copyright that prevents you from using it in commercial products. So this is the website right here, motorica.ai, and you can make dance cards with this. So I thought I would point that out there to you. It might, maybe they'll change their copyright later, and if so, then you would be able to use those in commercial products. But I have seen people successfully make dance cards and use them in motion matching systems using that. AI-based solution. So moving on, let me go ahead and show you the replication problem. So I'm going to play this as a listen server first. I'm going to set this to this. Let me see here. Give me a second. Okay, I might want to first off go over here and increase this to like 500. I mean, I could do 4. That's probably the reason why earlier I kept getting 4,000 and stuff, because I kept not entering the 0. If you don't enter the 0, it'll enter it. It'll think you're talking about meters a second instead of centimeters a second. So just be careful whenever you're entering that. It seems to be something new that they're doing. So I did this earlier, and it didn't look this good. And I think the reason why is because I'm on the server. That's probably why. Okay. So let's see. Okay, it's what in the world? I had it working like this before, and now it seems to be working fine. Interesting. What did I do? Okay, it's rubber banding. There it goes. It is rubber banding a little bit. So there are some problems with this, but I'm not seeing any desynchronization right now. Let me make, what did I do? So at one point it was rubber banding, and now it's not rubber banding. Okay, I don't have that set to replicates. And I have that disconnected. I'm wondering if this, like I said, I've seen some desynchronization problems related to this. Just slight desynchronization, almost unnoticeable, but I did notice some. Okay, so yeah. So it is so the interpolation on that root offset is slightly off on the others. It will be. So there is some amount of desynchronization because I don't believe it's actually replicated. So let's see if we have that problem whenever I open it as clients, because last time I couldn't even move. Okay, there we go. So here's one of the problems. I am playing on a dedicated server, and you'll see that I cannot even move. I seem to be stuck in place. And I can come in here and I can set this component to replicate, but I'm not actually sure that's even actually replicating the trajectory. I don't think it is, because I don't think that's actually handled that way. I think it's already handled for you, so I don't know why they would be getting stuck in place. And that actually doesn't even help, so I don't know. So there you go. There's the problem. On a dedicated server, it seems to not even work. And sometimes, whenever you run it from yeah, so see now it's not working at all. Not even. Wait, did I not change that? I didn't change that. Okay. So I have had some serious rubber banding doing this before, and right now it doesn't really actually seem to be rubber banding, and I don't really know why. So just know that there may be some problems running it. Oh yeah, so there is some desynchronization. So if you look at it, if you look on both sides, you'll notice that sometimes he moves in a different way on the other ones, and that's basically because well, it's not perfectly replicated. And I mean, I'm not sure how you would perfectly replicate that without it being super heavy on a server. So there has to be, I guess, some form of autonomy. So if you did replicate it, you'd have to be very careful. Anyway, so moving on. So the continuing pose cost bias can be used to fix problems where your character is hitching. So if your character is hitching while he's running, it could mean that you're looping back over on yourself too often, and actually decreasing that could fix that, but it could also cause other problems. So you have to be careful and not decrease it too much. If you do decrease it, and actually I'm not even in the Ubisoft one anymore. So I'll show you this without root motion. So without root motion, you'll see it basically works the same as it was before. But if I play this as a client, we'll see that it still works. So without root motion from everything, it works fine as on a dedicated server. So you'll see there is some amount of let's see, desynchronization there, huh? Yeah, I can't tell. It's kind of hard to tell. So let's take this off of 2-player, put it back on standalone. So let's see. Now you'll notice that it might look fine. I'm going to show you something here. So this is how it normally looks. And now remember, I'm not using root motion. There is some amount of foot sliding, and I can smooth that out by giving it a window on the play rate. And so what this does is it allows it to play it faster when needed or slower when needed. And so that's actually a pretty big window. It might not be appropriate to make it 1.5 or 0.5. It might actually make more sense to do something like 75 and 25. A small window like that, because if you give it a big window, in some situations, it may actually look funny. So you have to be careful not to give it too much room. But this can help prevent foot sliding. That, as well as this right here, is helping to prevent foot sliding. So this is a form of inertial blending. It's a newer inertial blending node. It's called dead blending. Gives you a little bit more control over the inertial blending. Basically, the extrapolation settings down here. It gives you more control over that stuff. So let's see. So the play rate, adjusting the play rate, and instead of having it 1-1, that can have a dramatic effect on your animation system. It can dramatically help reduce foot sliding. And also, your pose reselect history can help prevent hitching. So back to the hitching problem. If you're having a hitching problem where it keeps hitching, it may be that you need to that you need to increase this. And what this does is, this is basically saying don't reselect a pose until it's 5 seconds old. So, I mean, half a second old. So if the pose has been selected within the last half a second, then don't reselect it. That's what that means. The pose jump threshold time, it actually allows you to set a range of time where within that range, the animation will not jump. Let's see, don't jump to poses of the same segment that are within the interval this many seconds away from the continuing pose. So basically, you could say, hey, I don't want you to jump from this pose to a pose half a second in the past or half a second into the future along this currently playing animation. And so what that means is that if you have multiple animations, setting that to telling it don't go back half a second, but only affect it while it was in this animation, it could still jump to these other animations. So it doesn't prevent it from leaving that animation and selecting a different animation. And the max obviously allows you to set like how far forward it's allowed to jump. So if you're having problems with it jumping or skipping ahead in an animation, say you're playing a jog stop here, and you and his foot goes down right there, and then all of a sudden he's right here. If that happens, then you could say, okay, so I was at 0.17 and it jumped to 0.5. So I'm going to tell it don't jump within a quarter of a second or a half a second into the future. And so I could set that to 0.5 and it would prevent it from jumping from there to there within that animation. So that's just something to keep in mind. If you do have a problem with it skipping frames, then you might try setting the max, putting a cap on the max. And that's just saying that from 0 to 0.2, or in this case from negative 0.5 to 0.2 seconds into the future, don't jump within that range. You can jump outside of that range, but don't jump around inside of that range. So I'm not going to go over all these settings in this video. I might do a comprehensive video later on those other settings. I don't want to jump around too much here. But yeah, your continuing pose cost bias will allow you to lower it for all the animations in this database. The base cost bias, I've had to lower that on mine, actually, inside of here on my stops. And there might be a better way to mitigate that, but I actually lowered the base cost bias because the cost bias was like 33 whenever I would enter the stop database. And so it would not transition out of my loops into my stops. It would get stuck in the last animation that it was playing, and it wouldn't exit out of there. And so I had to lower the base cost bias in order to get it to actually play one of these animations after loading up this database. So if you ever use a chooser and you leave the loop database and you enter the stop database, but it's stuck in a loop, even though you're not in a loop database, then it's because none of these animations have a cost lower than the continuing cost to stay in that loop animation that it last played. So the looping cost bias, decreasing this will make it more likely that a looping animation gets selected, but it'll also make it more likely that you stay in a looping animation. So if you're having problems with it choosing the looping animations, then you might lower it. But if you need it to stay in it, then you might you should either reduce the continuing pose cost bias if you need it reduced for all of them, or if you just need it reduced for specific ones, you can come in here and say add notify state and override continuing pose cost bias, and you have to give it a an area. You can also just like span this across the entire animation if you want, but maybe it's just a specific part of the animation that you want it to stay in. And so you would add that, and over here under the modifier in details, you can reduce this as needed. If -1 is not enough, then try reducing it more than -1. I would try to keep that modifier as close to 0 as possible. And the reason why is because these data sets, they get normalized, and it can sometimes flatten things out and cause problems if you reduce this too much. So in other words, don't reduce it by -1000 because it's going to screw up. It's going to affect the cost of every other animation if you do so. So you can also add block transitions. So let's say you have a motion capture animation, and let's say the first 5 frames or 10 frames, your character is in a T-pose. Rather than going back and cutting that part out, you can actually right-click and add a block transition. I mean, not block transition, and exclude from database. And so if you added an exclude from database here, then it will not show up in the database. So if you find this animation in the database, the animation in the database will start from here, not from frame 0, because you excluded the first 10 frames. Now, as far as the block transition, this just basically tells it that we cannot transition into this part of the animation. So we can't leave one animation and enter this animation at frame 25, for example, because we're blocking it. We're blocking it from entering at frame 25. So that's what that's for. It can still play frame 25 if it chooses frame 15 and it continues into this area. It can continue into this animation, but it can't jump to that area. It can't jump to that area, but it can play it if it starts outside of it and plays forward. So the motion matched branch in, I am not going to lie, I don't really know what that is, but it has something to do with entering I'm assuming that it has something to do with entering a post search database, but I could be completely wrong. So I'm not going to touch on that because I really don't know that well. Of course, you can override the base cost bias too, and then you can sample attributes and events. I'm not going to go into that because I haven't messed around with those yet. But an attribute would be like a bone. So let's say I want to sample the bone. Yeah, I'm not going to go into this because I don't really know. I expected it to be something more along the lines of this, but it's not. So I'm not going to touch on that. But it seems like you can enter a sampling attribute ID. So that might be noteworthy. That pretty much sums it up for that. So moving on. So we've covered these. I wouldn't recommend mirroring, guys. Mirroring can actually cause problems. It can cause foot sliding, and it can also cause the character to tilt in funny ways. If he's leaning in one direction and it mirrors it in the other, it may not match up like you would expect it to. So sometimes whenever you mirror things, it can cause problems. So I would be very careful about mirroring. I'll just put it like that. Be very careful about that. The sampling range, it allows you to say, okay, I only want to sample this animation between frame or between time 0 and time 2 seconds. So moving on, so the pose search schema, we have our trajectory channel and we have our pose channel. So the trajectory channel is going to reflect the velocity and the direction we are traveling. It's going to keep track and sample all of that. And so we have our position, velocity, facing direction, so on and so forth. And our pose search or our pose channel here, it has our pose is whenever it's trying to match what frame of what animation would work best to play next after, say, frame 5. And it's going to base that off of velocity and position by default. And this is the reason why root motion is needed on the animations, even though we're not driving the capsule via root motion. We still need the root motion because the pose search database, the pose search itself, it needs to wait or to score the poses based off of how fast the foot is moving, what its position is, so on and so forth. You can also track the rotation. Anything you're tracking inside of here needs to be for whatever bone or whatever bone you're tracking inside of here. It needs to be collected on your pose history. So your collected bones, these collected bones needs to reflect what bones you've set up in your pose channel. You can set up phase. Now phase, I'm going to explain that, but don't select it. It will crash the engine, and then when you try to open it, it'll keep crashing. So let's see. So this is a sine wave, and a period would be from here to here, which is a cycle. It's when it starts back over again. A phase would be a fraction of this. So this part of the slope would be a phase. And so inside of here, if I select this, you'll see I have I believe that's the right hand, I mean. Yeah. So that's the right hand. This is the phase of the right hand. So if we were tracking the phase, then say we were on this frame, then it would score the other animations based off of the phase of the right hand, and that phase would be like this. And so it would look at the phase so far ahead in the animation, and it would try to it would score them based off of which phase matches this phase closest. So that's what phase means, from my understanding. Again, take everything I say with a grain of salt because I'm still learning, and this is still a pretty new system. So I'm not going to go into the rest of this, guys. That pretty much sums it up, I believe. Let's see. Okay, so sampling interval. So by default, it's sampling it every 1/4 of a second or 400ths of a second. And it's collecting 5 poses. It's sampling 5 poses every 0.04 seconds. So lowering this can actually make it can actually solve some problems. So, for example, if you're having problems during really split second changes in your animation, then if it kind of glitches out and the animation isn't being selected well, it's kind of snappy and it's jumping around, then it could be that lowering the sampling interval from 0.04 to 0.01 could fix that. It could make it smoother, and also increasing the pose count, but that's going to come at a cost. So for the most part, these settings right here seem to work fine. The default is 2. I've been setting mine to 4, but honestly, I'm not really sure how much of an improvement that adds to it. I think it does make it a little bit smoother. So I've went over play rate. Yeah. Let's see. Yeah, so in the pose search schema, you can also adjust this. It's the sampling rate. And this is different, I believe. So this is actually the rate at which it updates the samples. Let's see, the update rate at which we sample the animation data in the database. The higher the sample rate, the more refined your search will be, but the more memory will be required. So whereas I believe the sampling intervals is probably going to have a CPU cost, it may be safe to say that the sampling rate is going to have a memory cost. So maybe don't increase this too high, if at all. So your normalized settings, for example, if you're familiar with normalizing, it basically finds, I believe, from my understanding, it finds the lowest value and the highest value, and then it remaps it down to a range of 0 to 1. And what this does for the search is it makes the pose search more smooth. What I mean is that if you have some extreme values in your database, without normalizing it, it could cause some serious problems. And so they use normalization to normalize the values of things across the board so that the values are more predictable for the pose search. You can also, by default, I believe this is a per database thing, that it normalizes it per database. I believe if you want it to be normalized across all databases, I believe you have to choose one of these other ones. But I'm not going to really go into that and take what I just said with a grain of salt because I'm not really sure about that. But it does say that it'll index all the databases in the normalization set with the same schema if you select this one right here. And this is experimental. And then this right here means that it'll normalize it using, well, according to its deviation. That's a statistical terminology. You can look it up if you're unfamiliar with it. But anyway, so I think that's pretty much it, guys. Yeah, I'll see you in the next video.